how to solve rational equations. Equations as in, we have these rational expressions, like fractions or fractions with x in them. Now we're going to do what happens when we throw equal signs in there and we say solve for x. Any question that says solve, it really means solve for x. Figure out what x value makes this true. First step is I have to think about my excluded values because I don't want at the end of the problem to have forgotten, and it's important that I do it. So the first thing I'm going to do is think about excluded values. Things that x cannot be. The way I come up with those is I look at my denominators and I think, what is going to make this denominator 0? What will make this denominator 0? Nothing. What will make this denominator 0? Nothing. What makes this denominator 0? Well, if x is 0, that makes that denominator 0. So if at the end of the problem, I'm like, oh, 0 is one of my answers, I need to look back at this line and say, no, 0 cannot be an answer. That was the first thing I did in this problem, was decided 0 cannot be an answer. The second thing I do is I put everything on one side of the equal sign. In other words, I need to get either everything on the right side or everything on the left side. In this case, I'm going to get this 3/4 over to the left side. I'm going to do it by subtracting 3/4 from both sides. I turn this problem into 5 over x plus 1 over 3, and then at 3/4 I subtract over to the left side. I have this. Next step is I'm going to add all these together, or subtract in the case of the 3/4. So I need a common denominator. There's an x here, so I better put a times x in this fraction, and a times x in this fraction, because I'm trying to make all the denominators the same. Now at least they all have x in them. There's a 3 here, so I need a times 3 in this fraction, a times 3 in this fraction. Now all the denominators almost match, except there's this 4 in the third denominator that's not in the others. So I'll put a times 4 and a times 4. Now all of my denominators are the same. All of my denominators are 12x. I have 5 over 12x plus 4x over 12x minus 9x over 12x equals 0. Now if they all have a common denominator, I can add and subtract. I can put it all in one fraction. 12x is my denominator. On top I have the 5 plus the 4x minus the 9x, and it still comes out to 0. I just need to clean up this fraction. 5 plus 4x minus 9x, that makes minus 5x over 12x equals 0. Once I have all my fractions together, I'll add it and subtract it, and it's all one fraction. I simplify this fraction. In this case, this fraction doesn't simplify. And then I find the zeros of the numerator. I find the zeros of this. Before, at the start of it, I used the zeros of the denominator to get excluded values. Now I'm using zeros of the numerator to get my zeros. I'm figuring out what makes 5 minus 5x come out to 0. If I solve that, I get 5 equals 5x. X equals 1. X equals 1 is my answer as long as I go back to the top of my paper. I make sure that's not an excluded value. Nope, it was 0 was my excluded value. That was my only excluded value. So x equals 1 is a good answer. That is my one and only answer to this. Before we move on, let's just recap all the steps we took. Step 1 was I looked at my excluded values, and I did that by looking at my denominators, the zeros of my denominators. Step 2, I moved everything to one side. I took the 3/4 and I moved it to the left side. Then I added and subtracted all my fractions together to make it one giant fraction. And last, I looked at the zeros of the numerator. I figured out what makes 5 minus 5x 0. Let's try applying that to another problem. First step is I look for my excluded values. I think about this denominator, and this denominator, what the zeros of those denominators are. In this case, there are no zeros of 18. No x value turns 18 magically into 0. No x value magically turns 6 into 0. There is an x value that makes x plus 3 0. It's negative 3. My excluded value is negative 3. X cannot be negative 3. I just write this at the start of the problem. That way I remember at the end, if I get the answer -3, I say, oh, that's not true. I need to throw away that answer. Step 1 done. Step 2, I move everything to one side. So maybe I'll move everything to the left side. So 4 over x plus 3, that's already on the left side, that could stay. Plus 5 over 6, that's fine. But then I take that 23 over 18 and I move it to the left side by subtracting. Moved everything to one side. Next, I add and subtract. I need to get these all into one common fraction, one rational expression. I do that by using a common denominator. So here I have an x plus 3, and the others don't. So I need to put an x plus 3 here, and I need to put it in the second fraction as well. Then I see I have this 6 and this 18. 18 is just 6 times 3. So really, I just need to make sure all the denominators have a 6 times 3 in them. Right? This middle fraction has the 6, but I need to put a times 3 in there. And this last fraction doesn't have it at all. I need to put the whole 6 times 3 in there. 6 times 3. The whole 6 times 3. Now all three denominators have a 3 times a 6 times an x plus 3. Just each of them in their own order. So I'm going to combine the fractions. All of the denominators are 18 x plus 3. My numerators are 4 times 6 times 3 is 72. 3 times 5 is 15, so I have 15 times x plus 15 times 3 makes 45. 23 times x plus 23 times 3. I have 3 rational expressions, adding and subtracting. They all have a common denominator. So I'll write it all as one giant fraction. 18 x plus 3, 72 plus 15x plus 45 minus 23x plus 69. It's important that I put that 23x plus 69 in parentheses. That way I know to subtract the whole thing. That I know to distribute the minus to everything. This is 72 plus 15x plus 45 minus 23x minus 69 over 18 x plus 3, which has some big numbers in it, but not so big that I'm overwhelmed. If I do 72 plus 45 minus 69, I get plus 48. And if I do 15x minus 23x, I get negative 8x. Now I simplify this. It looks like I could take a 2 out of the numerator and denominator. 2, negative 9x plus 24. Negative 4x plus 24. On bottom, this is 2 times 9. X plus 3. 18 is 2 times 9. If I cancel out my 2's, I am left with negative 4x plus 24 over 9, x plus 3. I could factor more out at the top, right? There's a GCF of 4 or negative 4. I don't need to factor it out. I'm not going to, just because I see that's not going to cancel with anything on bottom. So I did it. I combined all my rational expressions into one thing. Remember, that wasn't the problem. That was just step 3. But we did that now. So now I just need to find the zeros of the numerator. Zeros of the numerator, meaning I go to my numerator and I say, hey numerator, what makes you come out to 0? Well, that's going to be when 24 is equal to 4x. So when x equals 6. this is my answer as long as it's not one of my excluded values. I do need a check. Scroll all the way back up to the top. Nope, not an excluded value. So my final answer is x equals 6. Yay. Another one. These are long. I'm not pretending like these aren't sometimes long, but as you get better at them, they get a little bit faster. First up, I find my excluded values. That's my zeros of my denominator. So one of my excluded values is going to be 0, because that would make this denominator 0. The other is going to be 5. My excluded values are 0 and 5. X cannot be one of those values. Those are my excluded values. Next, I move on to moving everything to one side. So I have 1 minus 8 over x minus 5 minus 3 over x equals 0. And just move that 3 over x to the left side. Done. Now I need to add and subtract. To do that, I'm going to need a common denominator. I have an x here. I better put an x in all of my other ones. While I'm at it, let's make sure everything has an x minus 5 in it. And although it looks like this first fraction has a 1 in it, yeah, I don't need to write 1s. Times 1 doesn't mean anything. So all my denominators are x over x minus 5, not x over x times x minus 5. My first numerator is 1 times x minus 5, so x squared minus 5x. Second numerator is 8 times x, and third is 3 times x minus 3 times 5. Now that they're all a common denominator, I combine it into one fraction. That makes x squared minus 5x minus 8x minus 3x plus 15. When I combine like terms, I have x squared minus 5x minus 8x minus 3x makes minus 16x plus 15. Possible something cancels here. I have a numerator that comes out to x minus 15, x minus 1. I did that. I saw I was going to factor, so I decided I should factor to see if anything cancels. Nothing does, so I'm done adding and subtracting. Finally, I move on to zeros of the numerator. So I say, hello numerator, what makes you come out to 0? What are the zeros of x minus 15, x minus 1? What makes this come out to 0? Well, x equals 15 is one of them, and x equals 1 is another. If those aren't excluded values, I'm done. 0 and 5. Nope, I'm good. Neither 15 nor 1 is excluded. Those are my answers. In this one, first I look for the excluded values. So what makes this denominator come out to 0? Well, if x is negative 1. What makes this 0? Well, that's if x is 1. And what makes x squared minus 1 equal to 0? Well, I can find the zeros by factoring. Oh, you know what? It's just going to be 1 and negative 1. So my only excluded values are negative 1 and 1. Now I move on to moving everything to one side. I add and subtract. To do that, I need a common denominator. All of my denominators are now the same. My common denominator is x plus 1, x minus 1. First numerator is 2x minus 2. My second is 1 times x plus 1, so x plus 1. My third is 2. If I put this all in one fraction, and combine like terms, I get this rational expression, which is interesting because here it looks like I have an x minus 1 on top and bottom. So I can cancel these out. And all I'm left with is 1 over x plus 1 equals 0. My last step is finding the zeros of the numerator. So it's me taking this and being like, okay, what x value is going to make that numerator come out to 0? And the answer is no x value. There's no solution. That's correct. For this problem, there's no solution. Say, maybe I didn't notice things canceled. When I was all the way back at this step, maybe I don't notice that there's an x minus 1 on top and bottom. Then I would say, okay, I simplified. I didn't actually, but I didn't notice that I didn't. So I say, oh, okay, I'm done. I combine my fractions. What are the zeros of my numerator? What makes x minus 1 come out to 0? Well, that happens when x equals 1. So I go to the top and I say, is that one of my excluded values? Oh my god, 1's an excluded value. That's so awkward. That means that this is not a solution. So there's no solution. I throw out all the x's that are excluded. The only one was 1, and that got excluded. So there's no solution left. The TLDR is that even if I mess up and I don't notice something cancels, my excluded values in this case saved me. So yay, noticing excluded values.